All right, so now we know a little bit about angles. Now let's talk about some different types of angles and some names of some angles. Let's see what I want to do. All right, what if I had an angle like this? I'm not going to draw the arrows on there just for the sake of time. Is that okay with you? It won't bother you, will it? Okay. So if we had an angle like this, and the degrees is less than 90 degrees, basically it's between 0 and 90 degrees. If it's less than 90 degrees, we have a certain name for this type of angle. Do you remember what that's called? It's an acute angle. Good. So you can write that down if you want to. Less than 90 degrees is an acute angle. If you had an angle like this, that's between 90 and 180, or I say, for the most, just to make it easy, I just say less than 180 degrees. If it's less, I'm sorry, not less, let's say if it's greater than 90 degrees, we'll say it that way. Technically it's between 90 and 180, but if I say it's greater than 90 degrees, we call this what? Obtuse, right? So you guys remember this stuff. And then one we used a whole bunch in geometry. Yeah, it would be this one, and that's exactly 90 degrees, and we call that a right angle. Alright, so that's acute, obtuse, right. Now here's one, this is kind of like the forgotten one sometimes. Oopsie daisy. There we go. Let's say we put a point right there. Okay, so there's a point right here. So this is actually two rays, isn't it? Now, I'll go ahead and put the arrows on this one. Look, here's the end point. I got a ray going this way, got a ray going this way. All right, so it's actually two rays, which makes an angle. So this is actually an angle. A lot of times we don't think of this as being an angle, do we? We think, oh, it's just a straight line. But it is an angle. How many degrees is this angle? 180 degrees. And what do we call this angle? A straight angle. Good. All right, and if you want to write the numbers in that they're equal to, that would be good. All right, so that's a straight angle, obtuse, acute, and right. And of course, we'll do a lot of stuff with that. What if you had... let's do this. What if you had this, and we'll make that a right angle, then we'll put one like right in here. Now remember, we talked about naming the angles. You can name the angles with the letters and stuff, but you can also use numbers if you like. I could call that angle 1, I could call that angle 2. Angle 1 is that one down here on the bottom. Everybody see that? Angle 2 would be this one right here. Sometimes it's a lot easier to name them with the numbers than with the letters, and it just depends on the problem and the author and when they decide, how they decide to name the angles. But if I did this is a right angle. I'll put a little box right there. It represents it's a right angle. These two angles, they add up to what? What do they form? They add up to 90 degrees. Whatever that angle is, I don't even know what that angle is, but I know that this one and this one adds up to 90 degrees. We have a special name for this. This is one that people get confused a little bit sometimes. But they have a special name for two angles that add up to 90 degrees. Do you remember? It's complementary, okay? Complementary. Let's write that down. It's not like a compliment like, oh, you look pretty today. It's an E, not an I. Complementary. All right, so that's complementary. Let's do another little example here. Let's go this direction, and let's go, yeah, we'll go like, I should have just made one big old line. Hold on. Alright, so here's one big line right here, and let's take an angle and just make it go about like that. Alright, and I'll call this angle 3 and 4 since I already used 1 and 2. Let's say we had two angles like this. Look at 3 and 4. Now they don't add up to 90 degrees. In fact, angle 4 is already bigger than 90 degrees, isn't it? But what did 3 and 4 do? They add up to 180 degrees. Add up to a straight angle, right? Which is 180 degrees. So we give that a name. If this is complementary, what do we call this? Supplementary. And how do we remember that? Look, this adds up to 90 degrees. This adds up to 180 degrees. C comes before S in the alphabet. There's no like super great trick. I just remember C comes before S, right? So 90 comes before 80. So the 90 and the complementary go together, and this the 180 and the supplementary go together. Can you remember that? It's pretty easy, isn't it? I mean, you usually remember one or the other word, and just people get confused on which one goes with what. Complementary goes with the smaller one because it's first, it's before the S in the alphabet. You with me? Supplementary goes with 180. All right, good deal. Now this just opens up just so many areas to do math in. Let's get rid of all this mess. I mean, you could do an example. Look at the example on top of page 5. I'll just sketch it out real quick here. And right there. And they say, okay, this angle right here is x, and this angle right here is x plus 40. Now look, I don't know either one of those angles, but I want to find out what each of them are. Okay, knowing this information right here. This is angle x. I don't know what it is, but I know this is 40 degrees more than this angle right here. So how in the world do I set this up? Well, I realize that these two angles do what? What's the relationship between those two angles? What do they do? Give me a word. Yeah, give me a word. Give me one word. We just talked about it. They're supplementary, right? And what do supplementary angles do? They do what? Now they do it. Right, add up to 180. So what am I going to do? I'm going to go x plus 40 equals 180. See how we set up the math? All right, so we take some geometry. You did this a ton in geometry, didn't you? You took some geometry principles and you set them up into algebra equations, and then you solve for x or whatever. So let's do this. X plus x is 2x. Subtract the 40 from both sides, which is 140 divided by 2. X is what? 70. So this angle right here is 70 degrees. You could find this angle right here two ways. You could just add a 40 to the 70, or you could do what else? What's another way to find this angle? Subtract it from 180. Either way, you still get the same answer, don't you? 70 plus 40 is 110, or 180 minus 70 is 110. You still get the same answer. So that's what this angle is, and that's what that angle is right there. All right? You can definitely see where you can do some math involved in this. They do a little bit more. Let me go through one more principle. They do an example with complementary. I don't think we need to go do that. But what if you had this? What if you had two lines that intersect each other, and you've got some angles formed? Angle 1 and 2. All right, and what do we call those? Any vertical angles, right? You use those a lot in geometry too, didn't you? We call them vertical angles. And I'll just do the angle symbol, okay? Vertical angles. Now, there's something that was unique about these angles. What was it? They're equal to each other. That's right. Vertical angles are equal, right? You use that a lot in geometry. So they are absolutely equal to each other. So, for instance, if let's get rid of that. Get rid of that. Let's put some values in here, just like we did. Let's say that z. And let's say this is 3z minus 80. All right, you look at the relationship between them. You say, oh, wait a minute, they're vertical angles. So what must be true? Well, they got to be equal to each other, right? So you set them equal to each other. So I take 3z minus 80. They don't add up to 90 or add up to 180. They're absolutely equal to each other. So 3z minus 80 is equal to z, and you just do your math. Subtract z from both sides, you get 2z. Add an 80 to both sides, you get 80. Divide by 2. Oh, I put an x. I'm so used to writing x. Z is what? 40. So that's what this angle is right here. So if that's 40, I don't have to do any more math. What's this going to be? I don't have to put that z in here and figure it out, do I? I know it's going to be 40. All right, so if this is 40, then this is 40 right here. Does it work out? Yeah, 3 times 40 is 120, minus 80 is 40. Yeah, it definitely does. So that's definitely how we can do some math. Alrighty, let's pause that. If you look at the bottom of page 5, I'm going to skip some of the stuff that they talked about in here. I think you already know that. Like if you have two segments equal to each other, you know how you put that little tick mark on there to show they're equal? You did that plenty, didn't you, before? All right. So I don't have to write anything down for that. That's pretty basic. It's covered in the book. But look at the very bottom of page 5. This is pretty interesting. It's in bold. You see it? It says it's permitted to assume that a line appears to be a straight line is actually a straight line. So watch. If I did this, I mean, you basically have to make an assumption and say, well, that looks like a straight line is probably a straight line. You are allowed to assume that. Okay, but if you had two lines that looked perpendicular, but you weren't sure, you can't just make assumptions about it. So if I did this, and that's all I had, where am I? There we go. And that's all I had right there. Can I assume that these two angles are 90 degrees?
No, because you don't have a box.
You got to have the box. That's right. You have to be told. You have to be told that this is a right angle, and the little box tells you that's a right angle. Now we're not making any assumptions, are we? Now we know for a fact that that's a right angle. You with me on that? So just don't assume that they're perpendicular because they look like it. I mean, who knows? It could have been like 89.999 degrees, right? Is that perpendicular? It's really close to it, but it's not, right? So I think that's kind of important. Something at the bottom of the page I think was good to see there. They go through some other things on page 6. If you look at the top of page 6, what is permissible and what's not permissible, I think we can skip that kind of stuff. All right. I'm not going to draw out the rest of this stuff. Let's just talk real quick. We talked about the different types of angles, the acute and obtuse and all that kind of stuff. We have that thing with triangles as well. So look at the very bottom of 6. I'm not going to write it out, but we have an equiangular triangle. If you have a triangle that's equiangular, it means all the angles are, what do you think? Equal. If I have, I'm just going to sketch this. This is going to be a really ugly sketch. I'm not going to take the time because I'm running out of time. That's pretty ugly. So if it's equiangular, actually, that means all the angles are equal to each other. If all the angles are equal to each other, that also means all the sides are equal to each other. Equiangular means all the angles are equal. What does it mean for all the sides to be equal? Equilateral, right? Lateral means sides. And also, watch, we also learned that a triangle has a certain number of degrees. All these angles add up to a certain number of degrees no matter what shape of triangle you have. How many degrees is that? 180, good. So if all three of these are exactly equal and they all add up to 180, what must each of those be? Each of them must be 60 degrees, right? So anytime you have an equiangular or equilateral triangle, all those angles in there have got to be 60 degrees. Now, the size could be different, right? Now, I don't know what the size is for these, but if I said one side was 5, guess what? What's this side going to be? And what's this side going to be? All right, pretty easy, right? You got it? All right, good deal. All right, let's pause that. Let's do a quick sketch on an isosceles triangle. If I would have taken the time, I would have had these already prepared and nice and looking all nice and stuff, but I don't. Isosceles means two of the sides are equal to each other. If these two sides are equal to each other, then guess what must be true about this angle and this angle? Those two are equal, right? The opposite angles are equal to each other as well. You with me on that? All right, so you can do a lot of stuff with that. So there you go. And you have another triangle. It's called scalene triangle. We hardly ever use that, but scalene, if equilaterals, all three sides are equal. If isosceles, two sides are equal. What do you think scalene is? None of the sides are equal. Okay, so they have no equal sides whatsoever. That would be scalene. All right, we good with that? When do we get out of here? 20, like right now. Okay, that's a good place to stop, I guess. All right, so tomorrow we will pick up on these transversals. Did you get a chance to try any of those homework problems? Did you recognize any of them at all? Not much? There's a few that you should have been able to do, isn't there? Yeah? No? All right. It was lesson 1, problem set 1. So, all right. All right, we'll continue tomorrow.